Alright, in this video we're going to be going over the study guide for the final exam. The problems that you see on this study guide will be similar to the problems that will be on the actual final exam given by your instructor. Alright, we'll start with problem number 1, where we're going to solve the equation x minus 3 divided by 3 plus x plus 5 divided by 2 is equal to 19 over 6. Alright, in this case here, we need to get rid of the numbers that are in the denominator by finding what they call a least common denominator. That would be the smallest number that's divisible by 3, by 2, and by 6. In this case, that number will be 6. So the least common denominator will be 6. So what we'll do here is multiply each and every term in that equation by 6. So we're going to have 6 times x minus 3 over 3, and then 6 times x plus 5 over 2. That's equal to 6 times the 19 over 6. And then we're going to simplify this by doing this. If we divide 3 into 6, that's going to go 2 times. And then if I divide 2 into 6, that's going to go 3 times. And for this term right here, where I get 6 times 19 over 6, those 6's divide out. So here's what I will have. 2 times the quantity x minus 3 plus 3 times the quantity x plus 5 equal to 19. And then we'll use the distributed property here. So if I do 2 times x, that's going to be 2x. Minus 2 times 3, that's 6. And then 3 times x will be a plus 3x. And then 3 times the plus 5 will be a plus 15. And that'll be equal to 19. And then next we'll combine like terms here. So if I do 2x plus 3x, that's going to give me 5x. Then minus 6 plus 15 will be a plus 9, equal to 19. So I have 5x plus 9 is equal to 19. And then to solve for x, well, to get the 5x by itself, I'm subtracting 9. I'm going to subtract 9 on both sides of this equation. And that will give me 5x is equal to 10. And then finally divide both sides by 5, since I'm multiplying that x by 5. I'll end up with x is equal to 2. So here x equals 2 is the solution to that linear equation. Okay. Alright, problem number 2 is solving by using the quadratic formula. In this case, we got x squared minus 2x plus 17 is equal to 0. So in this case, we're going to have to identify a, b, and c. Now in this case here, we do have a 0 on one side of this equation. So we can apply the quadratic formula by identifying a, b, and c. Your a is the coefficient of your x squared term, and that's an understood 1. The b is the coefficient of x, negative 2. Your c is the constant term, 17. Now the quadratic formula is this: x equal negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. And then we go ahead and substitute the a, the b, and the c in that quadratic formula, where the values of a, b, and c will be substituted in the quadratic formula. So here, your b is negative 2, so I'm going to have a negative of a negative 2 plus or minus the square root of b, again, that's negative 2. That's going to be squared minus 4 times a, which is 1, times c, which is 17. All that's divided by 2 times a, and a is 1, so it'll be 2 times 1. Now I'm going to simplify the numerator and the denominator. In this case here, negative of a negative 2 would be 2, plus or minus the square root of. Negative 2 squared will be negative 2 times negative 2, which is 4, minus 4 times 1, which is 4, and then 4 times 17 will be 68. And all that's over 2 times 1, which is 2. Okay, now I'm going to simplify what's underneath the radical. So here, if I do 4 minus 68, that's going to give me negative 64. So I'm going to have 2 plus or minus the square root of negative 64, all divided by 2. So I'm continuing from here to here. Now the square root of 64 would be 8. However, I do have a negative sign underneath the radical that tells me that I have negative 1 there. So the square root of negative 1 would be I. So the square root of negative 64 would be 8i. So I'm going to have 2 plus or minus 8i all over 2. And now I'm going to break this up into 2 parts here, because I can do 2 divided by 2, and then plus or minus 8i divided by 2. That way you can see when I do 2 divided by 2, that's going to be 1, and then plus or minus 8i divided by 2 will be 4i. So I have 1 plus or minus 4i, which is actually 2 solutions here. That is this, x is equal to 1 plus 4i, and the other one will be x is equal to 1 minus 4i. So those are my 2 solutions for that particular quadratic equation using the quadratic formula. Okay. Now problem number 3 is solving the equation by factoring. In this case here we got x cubed minus 14x squared plus 48x is equal to 0. Now in this case I need to factor this out completely. First of all, I have a common factor that I can take out. In x cubed, 14x squared, and 48x, there is an x involved in it. So I have to use the x itself because the x to the first is the common factor with the smallest exponent. So I use x to the first as the common factor. Now to get what's inside the parentheses, I'm going to divide each and every term by that common factor of x. So here, if I do x cubed divided by x, that's x squared, minus 14x squared divided by x, that will be 14x, plus 48x divided by x, that would be 48, equal to 0. And then we're going to factor that x squared minus 14x plus 48 into 2 binomials here. So I'll bring down the x. Now that x squared, I can break that up as x and x. The middle term is negative, the last term is a plus, so they both have to be negative. And the factors of 48 that would give me a minus 14x will have to be 6 and 8, because negative 6x and a negative 8x added together will give me a minus 14x as the middle term. So factored completely, I'll have x times x minus 6 times x minus 8 equal to 0. And then I'm going to set each factor to be equal to 0. So this means x is equal to 0, or x minus 6 equal to 0, or x minus 8 equal to 0. And then for each equation, I will solve for x. Now here x is equal to 0 is already solved for x. Now for the x minus 6 equal to 0, if I add 6, I'm going to get x is equal to 6. And then for the x minus 8 is equal to 0, if I add 8, I get x is equal to 8. So these are my solutions for this polynomial equation. X is equal to 0, x is equal to 6, and x is equal to 8. So those are my three solutions to that polynomial equation. Alright, number 4 is a radical equation that you have to solve and do the check. Here we got the square root of 5x plus 14 is equal to x. And we're going to solve this radical equation. But first of all, let me go ahead and rewrite the equation. Now we need to eliminate that square root. The opposite of the square root would be the square. So here I'm going to take the square on both sides of this equation. So the square root of 5x plus 14 will be squared. The x will also be squared. So I'm squaring both sides of this equation. What's going to happen is I'm going to get rid of this radical. So the square root of 5x plus 14 and u squared is going to be what's underneath the radical. 5x plus 14. And then that's equal to x squared. Because x u squared, you get x squared. So now we have a quadratic equation. Now I need to get a 0 on one side of this equation here. So what I'm going to do here is bring down this x squared. Now, if I move the 5x over to the right-hand side of this equation where that x squared is at, that 5x becomes minus 5x. And if I move the plus 14 over to the right-hand side of this equation, it will become minus 14. So what I'm doing here is subtracting 5x and subtracting 14 on both sides of this equation. And here I will get a 0 on the left side. So I get x squared minus 5x minus 14 is equal to 0. Now that x squared minus 5x minus 14, I can factor that out into two binomials here. So that x squared, I can break that up as x and x. The factors of a negative 14, that's going to give me a negative 5x, will have to be minus 7 and plus 2. And we can check by doing negative 7x plus 2x, that's going to be negative 5x. So I have x minus 7 times x plus 2 equal to 0. And then I'm going to set each binomial factor to be equal to 0. So this means x minus 7 equals 0, or x plus 2 equals 0. And then for each equation, I'm going to solve for x. So for the x minus 7 is equal to 0, if I add 7, that would mean x is equal to 7. Or for the x plus 2 is equal to 0, if I subtract 2, x equals negative 2. So I have two solutions, x equals 7 or x equals negative 2. But here I have to do the check because one of these could be an extraneous solution. Okay? And besides, the largest exponent in this equation is a 1. So that means there should only be one solution. So when I do the check, which you'll be required to do, I'll start with x equals 7. And then replace each x in the original equation with 7. So I have the square root of 5 times x, which is equal to 7. 5 times 7 plus 14, that should be equal to 7. Now I'm going to simplify the left-hand side, especially the radical. So 5 times 7 will be 35, so I have the square root of 35 plus 14. That should be equal to 7. 35 plus 14 is 49, so the square root of 49 should equal to 7. And if I take the square root of 49, I do get 7, which it does equal to 7. So here I have a true statement. So this is true. So I can say x equal to 7 is a solution to that radical equation. But I also got to do the check for x equal negative 2. Now I'm going to replace each x in the original equation with negative 2. So I have the square root of 5 times negative 2 plus 14. That should equal negative 2. Now 5 times a negative 2 is going to be negative 10, so I'll have the square root of negative 10 plus 14. That should equal to negative 2. Now if I add negative 10 plus 14, that's going to give me 4. So the square root of 4 should equal to negative 2. Now the square root of 4 is just going to be 2. And 2 equaling to negative 2 is a false statement, because 2 does not equal to negative 2. So I have to eliminate x equal negative 2 as my extraneous solution. So here the only solution for that radical equation would be x is equal to 7. Okay. Number 5 is solving the absolute value equation. 3 times the absolute value of 2x minus 5 plus 4 equal to 25. 3 absolute value of 2x minus 5 and then plus 4 equal to 25. The first step is to get the absolute value by itself. That means I need to move the plus 4 over to the other side and get rid of the 3 that's in front. Let's start with getting rid of that plus 4 that's on the outside. I'm going to subtract 4 on both sides. So that means I'm going to have 3 times the absolute value of 2x minus 5 equal to 21. Now I still got to get the absolute value of 2x minus 5 by itself. I'm multiplying it by 3, so I need to divide by 3 on both sides. So I have the absolute value of 2x minus 5 equal to 7. Now, since I have an absolute value equation, I can write this as 2 separate equations with the word or in between it. So the absolute value of 2x minus 5 equal to 7 means 2x minus 5 equals 7, or 2x minus 5 equal negative 7. And now for each equation I will solve for x. So for the 2x minus 5 is equal to 7, if I add 5, I'm going to get 2x is equal to 12. Divide both sides by 2, you'll get x is equal to 6. That's one solution. Now for the second solution, 2x minus 5 equal to negative 7, again will add 5 on both sides of this equation, but this time will be 2x is equal to negative 2. Negative 7 plus 5 will give you negative 2. Divide both sides by 2, x is equal to negative 1. So my two solutions for this absolute value equation would be x is equal to 6 or x equals negative 1. Okay. Alright, number 6 is an inequality that you'll be required to solve. Here we got 7 times x minus 8. And then we got the plus 3 is less than 6 times the quantity x minus 5 plus 3x. Now in this case here, on each side we'll use the distributive property and combine like terms. So on this left side, if I do 7 times x, that'll be 7x. Minus 7 times 8 will be 56. I'm going to bring down the plus 3, and that's less than. The right side, I'll use the distributive property by doing 6 times x, that'll be 6x. Minus 6 times 5, which is 30, plus 3x. And then we'll go ahead and combine like terms on each side. I'm going to bring down the 7x and do negative 56 plus 3. That will be a negative 53. Then that's less than 6x plus 3x is 9x. Then minus 30. Okay, now what I'm going to do here is get all the variables on one side of this inequality and the constants on the other side. It would be much easier to move the variables on the left-hand side, or to the left-hand side. So I'm going to move the 9x over to where the 7x is by subtracting 9x on both sides. So here 7x minus 9x is a negative 2x minus 53, and that's less than negative 30. Now to get that negative 2x by itself, I need to add 53 on both sides of this equation. So here I'm going to have negative 2x is less than negative 30 plus 53, which will be 23. And then to get the x by itself, we need to divide both sides by negative 2. But in an inequality, anytime you divide both sides by a negative number, your inequality symbol switches to the opposite direction. So here, that less than will become greater than. So the x is greater than. And I'll go ahead and leave this as negative 23 over 2. So here x is greater than negative 23 over 2. That would be the solution to that particular inequality. Okay, problem number 7. Here you have an absolute value inequality. Absolute value of 2x plus 13 is greater than 7. In this case here, we have a greater than. That means we need to write this as two separate inequalities with the word or. Now, had that been less than, then we have to write it as a compound inequality. But this says greater than. That tells us we need to write it as two separate inequalities here. The first inequality would be 2x plus 13 is greater than 7, or 2x plus 13, we switch the inequality symbol from greater than to less than and change the sign from a positive 7 to negative 7. So these are my two inequalities that I will get x by themselves for each one. So now for the 2x plus 13 is greater than 7, if I subtract 13 on both sides, that means I'm going to have 2x is greater than 7 minus 13 will be negative 6. And then divide by 2. X is greater than negative 3. Now here I don't switch the inequality symbol because I'm dividing both sides of this inequality by a positive number, so that inequality symbol remains the same. Now for the 2x plus 13 is less than negative 7, if I subtract 13 on both sides, here I'm going to have 2x is less than negative 20. That means negative 7 minus 13 will give you negative 20. Divide both sides by a positive 2. The inequality symbol remains the same, so the x is less than negative 10. So here, the solution to that absolute value inequality will be x is greater than negative 3 or x is less than negative 10. Okay. Alright, number 8. Here you're going to select the graph of a relation which is not a function, not one-to-one, and is one-to-one. Now, for something that's not a function is this. You cannot have an x value going to two different y values here. Like in this one right here. You got one going to positive 5 and one going to 11. You can't have this x going to two different y values. So here, this is a mapping that is not a function. Okay. Now we got to find out which one is not one-to-one. Not one-to-one means this. You can't have a y value with two different x values. That means not one-to-one. In this case here, that 3 has two different x values, negative 4 and negative 1. So this will be a mapping that is not one-to-one. Which means that mapping A is one-to-one. Because you only got one x to one y, one x to one y, one x to one y. And I might as well tell you that if it is one-to-one, then that means it must be a function as well. Because in this case, only one x to one y for each one, and one y to only one x. Okay? Alright, number 9. Evaluate the piecewise function f of x is equal to 3x plus 9 if x is less than 1, or x squared plus 1 if your x is greater than or equal to 1. And that's going to be for x is equal to 5. In this case, that x value is going to tell you which one of these we need to use. Since x is 5, that is greater than 1, so we have to use the x squared plus 1. So here, f of 5 will be equal to, here we're going to use that x squared plus 1 by replacing the x with a 5. So it'll be 5 squared plus 1. And then simplify. If we square the 5, you're going to get 25. And then 25 plus 1 will be 26. So here, in this case here, the value of that piecewise function when x is equal to 5 will be 26. Okay. Problem number 10. Here we're going to find the domain of this rational function. F of x is equal to 18x squared plus 123x plus 203 divided by x squared plus 5x minus 24. Well, it is a rational function because we have a numerator and a denominator. We want to find out what values of x that will make this denominator 0. So we're going to take that x squared plus 5x minus 24, set it equal to 0. Now it's a quadratic. We can factor this into two binomials here. So the x squared, I can break that up as x and x. The factors of negative 24 that will give me 5x will be a plus 8 and a minus 3. Here 8x minus 3x will give me the 5x. So I have x plus 8 times x minus 3 equal to 0. And then we'll set each binomial factor to be equal to 0. So here I'll set x plus 8 equal to 0, or I have x minus 3 is equal to 0. That's what this equation means. And then we're going to solve each equation for x. So here, for the x plus 8 equal to 0, if I subtract 8, you'll get x equal to negative 8. And then for the x minus 3 equal to 0, if I add 3, that means x is equal to 3. So these two numbers are the values of x that would give me a 0 in the denominator. So when I write the domain in set builder notation, it's going to be this: the set of all x such that x is not equal to negative 8 or x is not equal to 3. That would be the domain for that rational function. Alright, number 11 is to write an equation of the line passing through the points -1, -2, and 3, 6. And you're going to write the equation in slope-intercept form. So here I got -1, -2, and 3, 6. The very first thing you need to do here is find the slope using the slope formula, which is in this case m is equal to y2 minus y1 all divided by x2 minus x1. So here I'm going to let -1 be x1 and -2 be y1. 3 will be x2 and 6 will be y2. And let that be y1. Okay? And substitute in that slope formula here. So y2 minus y1 will be 6 minus -2 over x2 minus x1. x2 is 3, x1 is -1. 3 minus -1. And now we just simplify here. 6 minus the -2 would be 8. 3 minus the -1 would be 4. And 8 divided by 4 would give you 2. So the slope there will be 2. But we want the equation. So here we're going to have to use our slope of 2, and we could use either one of these 2 points here. I'm going to use the second point, 3, 6. That way I won't have to deal with a bunch of negative signs here. So if I use 3, 6 as the ordered pair, x1 will be 3 and y1 will be 6. Now my point slope form is this: y minus y1 is equal to m times the quantity x minus x1. And then we're going to substitute x1, y1, and m in this point slope form. So here I'm going to have y minus y1, which is 6, equal to m, which is 2, times x minus x1, which is 3. And then we're going to solve this equation for y. So if I bring down the y minus 6 equal the right side use of distributive property, you're going to get 2 times x, which is 2x, minus 2 times 3, which is 6. So I got y minus 6 is equal to 2x minus 6. Well, to solve for y, I need to add 6 on both sides. So I have the y by itself, that's equal to 2x. Here, -6 and +6, they're gone. So I'm left with just simply y is equal to 2x as the equation of the line passing through those 2 points, -1, -2, and 3, 6. Alright, number 12 is using the slope and y-intercept to graph the equation f of x is equal to 3/4 x minus 5. F of x equal to 3/4 x minus 5. Well, first of all, let's identify the slope. As you can see, it's in slope-intercept form, which is, of course, f of x is equal to mx plus b. Your slope is going to be the coefficient of your x term. In this case, that's 3/4. The b is the constant. That's the -5. That's the number added to or subtracted from your linear term. Now, we're going to use those to graph this linear function, starting with the y-intercept of -5. So on the y-axis, we're going to go down to -5 and draw that point, because that's the point where the graph crosses the y-axis. Now the slope is 3/4. Your rise is going to be 3. The run is going to be 4. Slope is always rise over run, if you recall. The rise tells you how many places you need to go up. The run tells, or down. The run tells you how many places you need to go either to the left or to the right. Here the rise is a +3, so from the y-intercept of 5, I'm going to rise up 1, 2, 3 places. The run is 4, so I'm going to run to the right 1, 2, 3, 4. My second point will be right here. So here I rose up 3 and run to the right 4. Okay? And I can do that again if I want to. Start here and go up 1, 2, 3, and then run to the right 1, 2, 3, 4, and get another point right here. Now, I'm going to connect those points like this. And this represents the graph of the linear function f of x is equal to 3/4 x minus 5. Okay. All right, number 13. Transformations of functions here. Here we're given the graph of the function f of x, which is this. We want to use that to make the graph of g of x, which is f of x plus 5 minus 3. Well, by looking at this, I see I'm adding 5 to the x. That tells me I have a horizontal shift. That's the x-coordinate being changed. And this -3 on the outside tells me I have a vertical shift. That means that the y-coordinate will be changing. So I have two different transformations going on, the vertical shift and the horizontal shift. The first one I do is the horizontal shift, because I'm taking whatever the value of x is, add 5 to it, whatever that is, I'm going to subtract 3 from it. So here I'm going to make my table of values here, table here. My ordered pairs for f of x. Well, by looking at this, I have an ordered pair of 3, 7. The other one is the ordered pair 7, 2. And the third one, that's going to be 9 and 5. Yep, 9 and 5. So those are my ordered pairs for the graph of y is equal to f of x, as you can see here. Now, I do the horizontal shift first, okay? Well, with a horizontal shift, I always do the opposite of what's given. It says a +5, so the opposite of adding 5 would be to subtract 5. So I'll be subtracting 5 from each x-coordinate here. And then the next column will be the vertical shift. I do exactly what it says. It says a -3, I will subtract 3 from each y-coordinate. Okay? Vertical, the y is changing. Horizontal, x is changing. Alright, so let's come up with the ordered pairs after doing the horizontal shift. I'm subtracting 5 from each x coordinate here. So for this first ordered pair, if I do 3 minus 5, that's negative 2. I'm going to bring over the 7. For the second ordered pair, if I do 7 minus 5, that will be 2. I'll bring over this 2. And then for this last ordered pair, 9, 5, if I subtract 9 minus 5, I'm going to get 4. So these are my ordered pairs after doing the horizontal shift. I'm going to use these ordered pairs to come up with ordered pairs after doing the vertical shift. And these last set of ordered pairs represent the graph of g of x. So here, I'm subtracting 3 from each individual y coordinate here. So, for the first order pair, bring over the negative 2. If I do 7 minus 3, that's going to be 4. The next one, if I do 2 minus 3, that's negative 1. Here I'm bringing over this 2, and I'm doing this 2 minus the 3 for that negative 1. For this last order pair, bring down the 4. 5 minus 3 would be 2. So these ordered pairs are going to represent the graph of g of x. So I'm going to graph that on the coordinate plane. So in this case here, negative 2, negative 2, 4 would be to the left 2 and up 4. 2, negative 1 would be to the right 2 and down 1. And then 4, 2 to the right 4 and up 2. Then I'm going to connect those dots in the same way as the graph of f of x is. And here I have the graph of g of x, which is equal to f of x plus 5 minus 3. Okay. Alright, number 14. Here we're going to subtract two functions f and g. We got f of x equal to 3x minus 1, and g of x is equal to negative 7x plus 2. And we're going to subtract by doing f minus g of x. Well, f minus g of x is the same as f of x minus g of x. And now my f of x, that's that 3x minus 1. So I have 3x minus 1 minus. Now, I'm subtracting the entire g of x from f of x, so I need parentheses here. And g of x is at negative 7x plus 2. And that's in parentheses. All of g of x is being subtracted from f of x. And now I'm ready to simplify this. Bring down that 3x minus 1. This minus sign will change the sign of each and every term in the parentheses. So that minus sign makes the negative 7x plus 7x. The minus sign makes the plus 2 a minus 2. And then we're going to combine like terms here. 3x plus 7x. That's 10x. And then minus 1 and a minus 2 will be minus 3. And that would be what f minus g of x will end up being. 10x minus 3. Alright, problem number 15. It's the composition of two functions here. Here we got f of x is equal to 2x plus 5 and g of x equaling to x squared minus 7. And we want the composition of f with g of x, or f circle g of x as I would call it. And that simply means this, f of g of x. Now, the inside is g of x. And g of x is at x squared minus 7. So that means I'll substitute that g of x with the x squared minus 7. So what I'm going to be doing here is evaluating f of x squared minus 7. But in this case, my f of x is the 2x plus 5. So now everywhere I have an x in the f of x function, I'm going to replace it with what g of x is. Okay? So here, this x will be replaced with what g of x is. That's the x squared minus 7. And in the 2x plus 5, that x will be replaced with whatever g of x is. In this case, again, x squared minus 7. So on the right side, I got 2 times the quantity x minus 7 plus 5. Now I'm going to simplify the right side. Using the distributive property, I'm going to have 2 times x squared. That's 2x squared. Minus 2 times 7, that's going to be 14. Plus 5. Now if I combine like terms here, I'll bring down the 2x squared. Minus 14 plus 5 will be a minus 9. So here, 2x squared minus 9 represents the composition of f with g of x. Okay. So that's the composition of f with g of x. Alright, number 16. Determine the functions of f of x and g of x such that f of g of x equals this expression 5 divided by x squared minus 3x plus 6, and that quantity is to the 6th power. Well, the inside function is your g of x. And that will help us determine what f of x is. So let's let this inside function for g of x be what's inside the parentheses here. That x squared minus 3x plus 6. So here we're breaking this up into 2 functions here. So this is what g of x would be. That x squared minus 3x plus 6. Well, that g of x was put in place of x for f of x, so f of x had to start off as 5 over x to the 6th power. So that's what f of x had to start off as, 5 over x to the 6th. So these are my 2 functions that would give me this when I compose f with g of x. F of x was 5 over x plus 6. G of x is the x squared minus 3x plus 6. In this case, we're working backwards. We're decomposing the 2 functions. Number 17. You got the function f of x equal to 2x minus 6. And we want to find f inverse of x. Okay. The first step is to replace your f of x with the y. So here we're going to have y is equal to 2x minus 6. The second step would be to interchange x and y. In other words, your x becomes the y becomes x. So here, this y will be your x, so this will be x is equal to 2 times x will become y minus 6. So I get x equal to y minus 6. Next step would be to solve this equation for y. So in this case here, I need to get y by itself. I need to move the minus 6 over by adding 6 on both sides. So here we're going to have x plus 6 is equal to 2y. And then to solve for y, divide both sides by 2. That means y is equal to x plus 6 all over 2. So that equation is solved for y. Now for the final step would be to replace that y with this notation, f inverse of x. So here f inverse of x will be x plus 6 all over 2. So this is what your inverse function for f of x equal to 2x minus 6 will be. F inverse of x will be x plus 6 all over 2. Alright, number 18 is using the graphing calculator to make a graph of this function y is equal to 2x squared plus 4x minus 3. And this is laid out in 5 different steps here. So here, this is where we use our graphing calculator. So in part A, it's just using the calculator to type in your equation. So here we're going to press the y equal to for our equation. And we're going to enter the 2x squared plus 4x minus 3. So this will be 2. For the x, we use our xt theta n for the x variable. Then we press this x squared button for the exponent of 2. So it'll be 2x squared plus 4x plus 4 xt theta for the x minus 3. Okay. Also make sure that plot 1, plot 2, and plot 3 are off. If they're on, it's not going to work for you. So to turn them off, you have to use your up arrow key to highlight either plot 1, plot 2, or plot 3, and then press enter to turn them off. Okay? Then press zoom 6. What zoom 6 does, it gives you the standard window. Zoom is the button at the top, and then the number 6 will be the standard window. So number 6 will give you that. That would be the graph of the parabola. So that's part A. Now in part B, you define the two x-intercepts of the function to the nearest hundredth, or to 2 decimal places. So here we're finding the zeros here, where these two, with this graph, cross the x-axis at these 2 points here. So to find that out, we press second and calculate, second trace for the calculate menu. We're finding the zeros, so we select number 2. And it should say left bound. What you want to do here is position your blinking cursor on the left-hand side of that first x-intercept, like I have up here. And you want to put it above the left x-intercept, and then press enter. And then for right bound, you want the blinking cursor below that first x-intercept, like I have here, using your right arrow key. And then press enter. And then after guess, we press enter. That will be your 0 for this function here, which is your first x-intercept. To 2 decimal places, that would be negative 2.58. Now for the other x-intercept, which is on the right-hand side, here we'll do the same thing. Do second and trace for the calculate menu and select number 2 for the 0. Now this time for the left bound, since we're finding this x-intercept here, we're going to put the cursor below that second x-intercept, because this goes from left to right. So the cursor will be below that second x-intercept for your left bound, and then for the right bound, we're going to put the cursor above it, and then press enter. And then after guess, we go ahead and press enter. That will be your other x-intercept. In this case, x equal 0.58. Okay. Now part C is finding the coordinates of the point where a minimum occurs. Well, that's the lowest point on this graph right here. And to do that, we press second and trace for the calculate menu, and where the minimum occurs, we want to select number 3 for the minimum. So we'll select menu item number 3 by pressing number 3. Now for the left bound, we want the cursor on the left-hand side of that minimum point. like I have here, and then press enter. And then for right bound, we want the cursor on the right-hand side of that lowest point on that graph, and then press enter. And then after guess, go ahead and press enter. Now, they want the ordered pair, both the x and the y, to the nearest hundredth, or to 2 decimal places. This says negative 0.999. Let's say negative 1.0. And that the y value, negative 5. Because here they want the ordered pair. Okay. Now part D is additionally make a graph of y is equal to x minus 1. Okay, so here we go to y equal to. Now we're going to keep the equation in y1, but we're going to use our down arrow key to go to y2. And type in x minus 1. Here's your xt theta button for your x minus 1. And then we're going to press the graph key. Here we got the graph of the parabola, and now we got the graph of that linear equation, y is equal to x minus 1. So that's part D. In part E, you want to find the coordinates of the 2 points where the line intersects the curve. So this line intersects that parabola in 2 different places here. Let's find this first point of intersection right here. To do that, we're going to press second and then trace for the calculate menu. We're going to select menu item number 5 for the intersect. Now, it should say first curve. What we want to do here is use our left arrow key to put the blinking cursor as close as we can on top of that first point of intersection like I have here. And then after that, you're going to press enter 3 times. 1, 2, 3. That's going to be your first point of intersection, and you do have to write down the x and the y values here. X is negative 2, y is negative 3. So my first point of intersection will be negative 2, negative 3. Negative 2, negative 3 is the first point of intersection. Now we need to find this other point of intersection, which is about right here. So again, second, trace, and then select menu item number 5 for the intersection. Now this time, for under first curve, we're going to put that blinking cursor on top of that second point of intersection, or get it as close as we can to that point of intersection. And then press enter 1, 2, 3 times. There's your other point of intersection. 0.5, negative 0.5. Let me white out this point, that negative sign. Okay, because it is 0.5, negative 0.5 as the other point of intersection. Okay, so that's how we use our graphing calculator to come up with our answers to that particular problem. Alright, number 19 is a graph of a parabola in 4 different steps here. Part D is on the next page. Here we're going to sketch the graph of the parabola f of x equal to x squared plus 4x minus 5 by following these 4 steps. In part A, you're going to find the y-intercept. Now to find the y-intercept, you always let x equal 0. In other words, we're going to substitute each x in this function with 0. So here, f of 0 will be 0 squared plus 4 times 0 minus 5. 0 squared is 0 plus 4 times 0 is 0 minus 5. And that's going to end up being negative 5. So f of 0 will be negative 5. Then part B is to find the x-intercepts here. Anytime you're finding the x-intercept, you always set f of x to be equal to 0. So our f of x is at x squared plus 4x minus 5. We set that equal to 0. Now we can factor that into two binomials here. So x squared plus 4x minus 5 will be this. Break that up as x and x. The factors of a negative 5 that will give me 4x will be plus 5 and a minus 1. So I have x plus 5 times x minus 1 equal to 0. And then we set each binomial factor to be equal to 0. So this means x plus 5 equals 0, or x minus 1 equal to 0. And then for each equation, we'll solve for x. So for the x plus 5 equal to 0, that means x is equal to negative 5. Then for the x minus 1 is equal to 0, that means x is equal to 1. So these are my two x-intercepts here. At x equal negative 5 and at x is equal to 1, that parabola will be crossing the x-axis at those x values there. And in part C, you're going to find the coordinates of the vertex by using the formula for the x-coordinate of the vertex. Now, we haven't talked about completing the square. But here we use that x equal negative b over 2a to help us find the x-coordinate of the vertex and then substitute in the original formula, f of x. So if f of x equal to x squared plus 4x minus 5, your a is the coefficient of your x squared term. That's going to be 1. The b is the coefficient of x. That's 4. And here we use that x equal negative b over 2a to find the x-coordinate of that vertex. So here, we're going to have a negative b, which is 4, over 2 times a, which is 1. So I have negative 4 over 2 times 1, which is 2. Negative 4 over 2 will be negative 2. So I know what my x-coordinate of that vertex is going to be. Negative 2. Now to find the y-coordinate of the vertex, I replace each x in the f of x with negative 2. So in this case here, f of a negative 2 will be this. Negative 2, and that's squared, plus 4 times negative 2 minus 5. Now, negative 2 squared is negative 2 times negative 2. That's going to be 4. And then 4 times that negative 2 will be minus 8 plus, no, minus 5. So now 4 minus 8 is a negative 4. Negative 4 minus 5 will be negative 9. So your y-coordinate of that vertex is negative 9. So my vertex will be the ordered pair negative 2, negative 9. Okay, so now on the next page, I'm going to go ahead and use these points and a point symmetric to the y-intercept with respect to the axis of symmetry of that parabola to sketch the graph. Now, I know what my y-intercept is. It's negative 5. So I'm going to go down to negative 5 on the y-axis and draw that point. In part B, my x-intercepts are negative 5 and 1. So I'm going to go to negative 5 on the x-axis and draw a point there. And I'm going to go to positive 1 on the x-axis and draw the second point there. My vertex was negative 2, negative 9. So I'm going to go to the left 2 and down 9. And draw the point. Now, what I'm going to do here is draw an axis of symmetry. That axis of symmetry goes through the vertex. And my vertex is negative 2, negative 9. So the axis of symmetry will have to be the equation x equal negative 2. Now, compare the distance from this y-intercept to your axis of symmetry. That distance is 2 places to the right. So my other point on the left side will have to be 2 to the left. So I had to land right here. Because the axis of symmetry is where the right side has to be the mirror image of the left side. So if this y-intercept is 2 to the right, this point has to be 2 to the left. So these are all the points that I'm going to need to draw the graph of the parabola. That looks like this. Okay. So that's the graph of the parabola f of x is equal to x squared plus 4x minus 5. Okay. Number 20. Use synthetic division and the remainder theorem to evaluate the function f of x equal to x cubed minus 2x squared minus 29x minus 42 for x equal negative 5. Okay? Well, using synthetic division, that x equal negative 5, that's going to be my divisor. Now, in the f of x function, there are no missing terms here. I got x cubed, I got x squared, I got the x, and I got the constant. So I can go ahead and write their numerical coefficients. For the x cubed, that coefficient is 1. For the x squared, that coefficient is negative 2. For the x, that coefficient is negative 29. The constant is a negative 42. Now here's how we do synthetic division. In this case, I'm going to bring down the leading coefficient in the bottom row. That's the 1. And then I'll multiply that number, which is a 1, times its divisor of negative 5. So 1 times negative 5 would give me negative 5. That negative 5 goes underneath the negative 2. So if I add negative 2 and 5 together, negative 2 and negative 5 together, you'll get negative 7. And I'll repeat that process until all the columns are filled. So here I'll do negative 7 times negative 5. That's going to be a positive 35. And then add negative 29 and 35 together, you'll get 6. And then finally do 6 times the negative 5, which will be negative 30. Add these two numbers together, negative 42 and negative 30. Negative 72. Now the last number in the last row is your remainder. Not only that, that would be the value of this function when x is equal to negative 5. So I can say that f of negative 5 would be equal to negative 72. Okay. That's how we apply synthetic division and the remainder theorem to evaluate any function at any specific x value. Okay. Number 21. Use the rational zero theorem and synthetic division to find the zeros of the function f of x is equal to x cubed plus 8x squared plus 11x minus 20. Okay. So here we're going to need factors of the constant term, that's negative 20, and factors of the leading coefficient. The leading coefficient is the coefficient of the variable to the highest power. The highest exponent is x cubed, its coefficient is 1. But that factor is just simply plus or minus 1. Okay? Now the factors of 20, I like to list those in pairs, by the way. So the factors of 20, I'll start with the 1, using plus or minus symbols, plus or minus 1, and then plus or minus 20, because 1 goes into each number. Let's see, 2 is divisible by 20. Let's try 2 and 10. So it'll be plus or minus 2, plus or minus 10. 3 can't go into 20 evenly, but 4 can go into 20 5 times. So it'll be plus or minus 4 and plus or minus 5. And I know 5 goes into 24 times, but 5 and 4 is the same as 4 and 5. So these are all the factors of 20, or of negative 20. Now the only factors of 1 would be plus or minus 1. Now for my possible rational zeros, will be the factors of your constant term in numerical order: plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20, all divided by the factors of your leading coefficient. And there's only one, that's plus or minus 1. Well, each one of these divided by plus or minus 1 will be each one of these in the numerator. So I'll have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. These are the possible rational zeros for that particular function. Now we need to test each possible rational zero using synthetic division. And we do that until we get a number that gives us a remainder of 0. So let's start off by testing x is equal to 1. So my divisor will be the 1. Will be my divisor in the synthetic division. In f of x, there are no missing terms. I have x cubed, x squared, x, and a constant. So we write the numerical coefficients for them. So for x cubed, the coefficient is 1. For x squared, it's 8. For the x, it's 11. The constant is a negative 20. So I'm going to bring down the 1, which is my leading coefficient in the bottom row. And then we're going to do 1 times 1, which is 1. That 1 goes underneath the 8. Add the 1 to that 8, you're going to get 9. And then do 9 times 1, that will give you 9. And then 11 plus 9 will give you 20. And then finally 20 times 1 will give me 20. Negative 20 plus 20 is 0. And I can stop right here with the synthetic division use here, because my remainder is 0. That tells me that x equals 1 would be a solution to that, will be one of the zeros of that polynomial function. Now to find the other zeros, this is what I'm going to do here. That quotient where I got the 1, the 9, and the 20, that's going to be my quotient here. That's what I'm going to set equal to 0 to find out what my other zeros are. Because here, the 20 is the constant, the 9 is the coefficient of x, this 1 is the coefficient of x squared. So, this is what my quotient is. X squared plus 9x plus 20. That's going to be set equal to 0. And then I'm going to factor x squared plus 9x plus 20 into two binomials here. Let's see. X squared would be x and x. The factors of 20 that would give me 9x will be a plus 4 and a plus 5. So I have x plus 4 times x plus 5 equal to 0. And then I'm going to set each binomial factor equal to 0. So this means x plus 4 equal to 0. X plus 5 equal to 0. And then for each equation, I'm going to solve for x here. So for the x plus 4 equal to 0, that means x is equal to negative 4. So there's the other 0. And now for the x plus 5 equal to 0, subtract 5 on both sides. You get x equal negative 5. So that's the other 0. So the zeros for that polynomial function using the rational zero theorem and synthetic division will be 1, -4, -5. Alright, number 22. Use Gauss-Jordan elimination to solve the system. Now here you're going to use your graphing calculator for this one. This one we got 3x minus 4y is equal to 11. 2x plus 3y is equal to -4. I'm going to write this in the form of a matrix here. The first column will be my x's here, so I'll have a 3 and a 2. The second column will be my y coefficient, so I have -4, -3. No, -4 and just 3. The vertical bar separates the coefficients of x and y from my constants. That's the equal sign. And my constants here are 11, -4. Okay, now I'm going to show you how this can be done using the graphing calculator. Alright, in this case here, I'm going to enter this as a matrix here, so I have to use second and matrix. Now, I'm putting in a new matrix here, so I'm going to use my right arrow key for the edit. And I'm going to store this in matrix A. So I select number 1. Now, I have to tell it how many rows and how many columns I'm going to need. In this case, I have 2 rows and 3 columns here. So that first number will be the number of rows here. In this case, it's going to be 2, so I type in 2. Then use my right arrow key to go to the second number, which is the number of columns. In this case, I have 3 columns, so I'm going to type in the number 3 and then press enter. Now, I'm going to enter each number row by row. So this row, I'm going to enter row by row, starting with 3, then -4, and then 11. Pressing enter after each entry, so I type in the 3 and then enter, and then -4, enter, and then 11, and then enter. And it'll take me to the next row where I have to enter this next row of numbers here. 2, 3, -4. So I type in 2, enter, 3, enter, -4, enter. Okay. Now to get out of it, I press second and quit. And then next I'm going to press second and exit -1 for the matrix. Okay, now I'm going to go to the menu that says Math. So I'll use my right arrow key for Math. And then I'm going to use my down arrow key to find the menu item that says RREF. And here it is right here. RREF. That is Reduced Row Echelon Form. I'm going to select that item by pressing Enter. Now I stored this in matrix A. So here I'm going to do second and then matrix second exit -1. And I stored it in matrix A up here, so I'm going to select number 1. And then close the parentheses. And then finally press enter. Now this will be what's in reduced row echelon form, and I would expect you to copy that off that screen, which is this 1, 0, 0, 1, and then 1, -2. And let me explain these numbers in the last column, the 1 and the -2. That's your x and your y value here. So here your x is 1, your y value is -2. So that ordered pair for that system of equations using your calculator, which is what it does Gauss-Jordan elimination, that would be 1, -2. Okay. Alright, number 23 is using Cramer's rule to solve this system. 4x plus 3y is equal to 15, and 2x minus 5y is equal to 1. Now, in Cramer's rule, you have three different determinants. One for d, the other one is for d sub x, the other one d sub y. Now, in the d, you're always going to have your x and the y coefficients. In this case here, your x coefficients are here, 4 and 2. And we have to put those in the order that they appear. Your y coefficients are here, 3, negative 5. That represents your D matrix. Your D sub x matrix is this. Instead of the x's being in the first column, your constants will be in place of that. And then you'll have your y coefficients there. In this case, the constants here are going to be these two numbers here, 15, 1. And then the y coefficients here, 3, negative 5. And then finally for the d sub y, you'll still have your x coefficients in the first column, but instead of the y coefficients in the second column, it will be your constant. So here, the x coefficients will be the 4 and the 2. The constants here, 15, 1. Now we're going to find the determinants for all three of these matrices here. So starting with the D, its determinant will be this. We multiply 4 times negative 5, that would be negative 20. And it's always going to be minus the product of this diagonal here, 2 times 3. That's 6. So we got negative 20 minus 6. That's negative 26. Okay, it's the product of this diagonal going in this direction minus the product of this diagonal going in this direction. D sub x, we do the same thing. The product of this diagonal in this direction, 15 times negative 5, that's a negative 75, minus the product of this diagonal, 1 times 3, that's 3. And now negative 75 minus 3. That's negative 78. And then for d sub y, that's the product of this diagonal here, 4 times 1, which is 4, minus the product of this diagonal, 2 times 15. That's 30.